Hello and welcome, everyone. Thank you for joining us today for a new BayesiaLab webinar. Calling today's event a BayesiaLab webinar is actually a bit of a misnomer. What you will see today is a new tool that extends the BayesiaLab ecosystem beyond the Bayesian network paradigm. This new product is called HellixMap, and you will learn all about it from Lionel Jouff, who will be joining us from his office in Laval, France. Given that we have a very full program today, I'll be brief and only mention one more thing. There is a chat box on your screen where you can post your comments or questions, or simply say hello and let everyone know where you're joining from. And as we only have 1 hour, we may not be able to address all your questions live. In any case, we will make sure to respond to you individually afterwards. So let me now add Lionel to our stream. Hi, Lionel. How are you today?
Doing well. How about you?
Very good, very good. It looks like our audio and video connection worked.
Perfect.
So I'd say let's get started. Lionel, the virtual stage is yours.
Thank you, Stefan. So I guess everybody see my screen, right? Confirm, Stefan? Yeah. So yes, today's webinar is about HellixMap. So it's a product we have started to develop in January, so 6 months ago. And that allows to, first, it was just meant to visualize the graphs we were creating via BayesiaLab, but now we have also included Hellixia within. So it's allowed now also to generate and then share knowledge that is represented with graph, not just Bayesian network, right? So let's start with our usual slide here about BayesiaLab workflows. So within BayesiaLab, you know, the engine, the heart of our expert system, or the brain, more precisely, is a Bayesian network, which is a directed acyclic graph. And so this Bayesian network has a qualitative part, so the nodes and the links that represent either correlation or causation, and the nodes represent the dimension of the domain, and they contains, you know, exclusive states. And then within these nodes, we have conditional or marginal probability. So this is a quantification part of the network. And then once we have the network, we can use it as a probabilistic expert system for updating, you know, posterior probabilities given a set of evidence that we have, right? So in order to create this Bayesian network, so we can obviously use machine learning. So this is what we do, what we call knowledge discovery. So we bring a data set and we can machine learn the structure and estimate the probabilities based on the data that we have at our disposal. Right? We can also do knowledge modeling. So we are organizing lots of brainstorming sessions that allows us to, you know, capture the knowledge of a group of experts. So very useful. So sometimes, you know, before just people are going to retire, we organize this session just to capture their unique knowledge. And then based on the knowledge of the group, we build the structure and we estimate the probabilities. And this way we have a decision tool that is based on the collective knowledge of the group. Right? And we have, since 2.5 years now, Hellixia that can be used for doing what we call knowledge mining. So we are interacting with the different LLMs, the large language models that are available, and we are building graphs with Hellixia. So we are extracting, mining the knowledge that is encoded in the deep neural network of these large language models, right? So obviously, so these are 3 sources of knowledge, but we can, you know, they are not exclusive. So which means that we are usually using expert knowledge when we do machine learning. We can also use machine learning when we do expert knowledge modeling. And now we can use Hellixia for helping machine learning and brainstorming sessions. Right. So once we have a fully specified Bayesian network, which means the structure and the probabilities, then we can use it, as I said, as a probabilistic expert system that allows to do decision support. And this can be going through, you know, simulation, setting evidence on root nodes and see how this is impacting, you know, the other nodes, right? Or we can do diagnosis, which means that we are observing consequences and updating or backpropagating, if you will, this information to the other nodes, so the effect nodes, the causes nodes, sorry. Then we can also obviously interact with the network to analyze the model of the domain. And we can also optimize. So usually when we have some kind of causal hypothesis associated with the graph. And at the end of the day, we can also obviously do risk management because we are dealing with probabilities, right? So this is now the basic workflow of BayesiaLab. But we can also obviously use these graphs, so the qualitative part, for knowledge interpretation, right? Which means that we can visualize this graph, right? We can explore them just to discover the knowledge that is encoded in this network, and we can share this knowledge via the graph. So this is one of the most important feature of graphs of Bayesian networks and other type of graphs. And this is something that we can understand. So this is absolutely the opposite of a neural network where this is a black box. Here, with a graph like a Bayesian network or knowledge graph, you can understand everything is interpretable, right? So we are going to focus on this part today. But let's talk about Hellixia, which is, our subject matter assistant that we have developed since 2.5 years. And this tool allows us to, do knowledge mining. So it allows us to do lots of other things, but one of the main features is really knowledge mining. So which means that we can use, the knowledge that is encoding in the deep neural network to create automatically knowledge graph, semantic flowchart, causal semantic diagrams, causal network, risk-centric causal networks, right? So I'm going to describe all these type of graph in a few seconds. So let's start with a knowledge graph. So a knowledge graph, is a structural representation of the information that you have that captures the relationship between entities, right? So it can be concept, people, organization, or whatever. And then the nodes are, in this graph, represent entities. The arcs, they are not correlation. They are semantic relationship between these entities. And they can include, taxonomy. They can be partitive, they can be attributive, they can be causal, functional, or temporal, or even spatial, right? So here, I have an example where I have created 17 nodes. So just within BayesiaLab, I've created all these nodes manually. And then I can use these nodes and ask Hellixia to create a knowledge graph based on these nodes. So if I do that, I end up with this knowledge graph, so which at the end of the day is a kind of subset. There are lots of little knowledge graph here, or small knowledge graph. So we have, for example, cat, that is a mammal, right? A car is powered by an engine and facilitates traveling. Water is transparent. Lighter creates fires that can be used for lighting cigarettes, and that produces smoke, and the cigarettes are also producing smoke. Berlin is a capital of Germany, and is also a capital. Paris is a capital of France, and it's also a capital. Germany and France are neighbors, and they are both in Europe. Right? So if we use these 17 nodes, use Hellixia for creating a knowledge graph based on these isolated nodes, we end up with this kind of knowledge graph, right? Now let's talk about the causal semantic diagram, which is a second type of graphs that we can create with Hellixia. So this is quite similar to a knowledge graph, but now the main difference is that the relationship between the entities are causal, right? So not just spatial or partitive and so on. So here we have causal relationship, but we call that a causal semantic diagram because it's not really a causal network, since we did not quantify the relationship, right? So it's purely descriptive, qualitative, right? We have also a way to create semantic flowcharts. So these flowcharts are more or less very similar to a knowledge graph and causal semantic diagrams, but now the arc represent temporal dependencies, right? So which may or may not correspond to causal links, right? Then we have causal network. So this, I guess you are more familiar with that. So in a causal Bayesian network, this is a Bayesian network that is fully specified and where the relationships are causal, right? So not just mere, association, but really should represent causal links, right? And Hellixia so creates these causal relationships and also estimate a causal effect or direct effect, if you will. So these direct effects are ranging from -1 to 1. So when it's negative, the arc is represented in red. When it's positive, it's in blue. And so within the family of causal networks that Hellixia can create, we have two subtypes. So we have one, which is only in BayesiaLab, so I'm not going to talk about this one today. But otherwise, within HellixMap, we can create constraint-based network, right? And so that are using different classes of nodes. So the first type of causal network that we can qualify as general. So they are based on 6 classes. So we have the event, the aggregate, the intervention, the confounding, the main criterion, and the consequential variable. Then we have the risk-centric, so where we have also different classes, 6 classes. So we have triggers, control, events, main risk, consequence, and mitigants, right? And these classes of nodes reflect indeed the role of these nodes, right, in the causal model. So, for example, events will have a direct influence on the main criterions, right? The mitigants nodes will mitigate the consequentials, right? So let's see what is a general causal network with an example here. So we have the main criterion, right? So this is a primary outcome or the condition of interest, if you will. Then we have a node called aggregate. Usually we are trying to aggregate, the events that have an impact on the main criterion. So in this example, we have 3 events. So event A is a specific event that have a direct impact on the main criterion, but that is aggregated in the brown node here. Right? So event B, same thing. And the same thing with the third one, event C. Then we have in yellow here the intervention node. So this is a variable that can have an action that alters the likelihood of the events, right? And can also have a direct impact on the aggregate nodes. Then we have the confounding factors, so that can have a direct impact on the event, the aggregate, and also the main criterions, hence the name of confounding. And then we have the consequences. So we can have positive consequences, negative consequences. So just 2 types of consequences. And so this is the structure of our general causal network, right? Then we have a second one, which is the risk-centric causal network. So this is based on Fenton taxonomy here. So we have the main criterion, so the main risk. So here this is something, a risk or event or condition under analysis that represents something that is not desirable, right? So an undesirable outcome. Then we have the event nodes that we have, so it can be called sub-risk if we want, that have a direct impact on the main risk. Then we have the conditions that can trigger these events, right? So we have, in this example, trigger A, trigger B, and then we have variables that can control this, right? So that will reduce the likelihood of event A, right? So we have this in blue. Then we have the consequences, right? So this is when the main risk occurs, this can lead to consequences X, Y, and so on. So direct negative impact. And then we have the mitigants, right? So these are actions that you can put in play in order to reduce the negative effect of the main risk, right? So these are the kind of network, causal network that we can generate automatically with Hellixia, right? So now we are going to switch to HellixMap, right? So this is the main topic of today. And HellixMap here is a web interface that allows you to visualize the graph, to share them, and to generate them. And the first way to create a graph within HellixMap is to upload an XBL file, right? So a network that had been saved within BayesiaLab, right? So you have this Bayesian file that you are uploading, and then you're going to be able to share it, visualize it, explore it within HellixMap. You can obviously directly use BayesiaLab for publishing. So you go in the tools menu, and then you can publish your network directly in or to HellixMap, right? And then we have Hellixia that is obviously available in BayesiaLab, so you can use for generating your graph in BayesiaLab and then publish them to HellixMap, or directly use Hellixia within HellixMap to generate these 5 types of graph I just mentioned, right? And then once we have HellixMap, you can really do the knowledge interpretation part, so you can visualize, explore, and share very easily all your graphs. So the knowledge that is encoded in these graphs. So when you connect to HellixMap, so you have this welcome page, right? So the URL is hellixmap.bayesia.com. So you arrive there and you have to sign in. Well, unless you have already a link to a graph, you don't have to sign in. But if you just connect directly to HellixMap, you have to sign in. So just create an account. And then so you just here, either you already have a Bayesian account and then you set your credentials, or you click on register, and in a few seconds, you're going to have an account, and then you will be able to exploit HellixMap. So this is the landing page, if you will, when you are connected. So you can see on the left, well, on the left, which is more or less 3/4 of the screen, you have the public graph that have been published by other users than the one I'm using right now, right? So they appear so with this little lock here that is open and with a gray background, right? So these are public networks that you can directly access, share to. And here right now, so I'm going to see, we are going to be able to, for example, go to one network that I've chosen here. That is about, this is a network I've created with BayesiaLab, and that analyze, the book Thinking Fast and Slow. But when I say analyze the book, it's not correct. It's more like I just enter as a query, if you will, a node called Thinking Fast and Slow by Daniel Kahneman, and then I ask to generate a risk-centric causal network on cognitive biases, right? So this is how I've created this graph, and then I have used BayesiaLab to publish it, right? And then it's available in HellixMap. And this is then the representation of this graph. So I can switch to the dark mode. I prefer this representation here. And then we have, the main risk here in this risk-centric causal network is cognitive biases, systematic errors in thinking that affect decision and judgment, right? So we have the main, the main event, if you will. So those biases at the end of the day. So we have the first one, which is, the system one thinking dominates. So fast, automatic, intuitive thinking overrides deliberate rational analysis. Then we're going to have the anchoring biases. So we have also comments. So each time you over a node or a link, you have you can display or show the comment that is associated with these elements, right? So here we have the confirmation bias. We have then the loss aversion, right? With the effect that is also quantified. You see this one is 65, and the availability heuristic that is activated, right? So we can explore the graph like that, so it's kind of interactive here. And then we can also use contextual menus. So if you make a right click on this node, system 1 thinking dominates, we can then trigger the function neighborhood, right? So if I do that, I can then define what is the radius. So by default, it's 1, but it's using the last value you have used. So here I'm using 1, which means that I'm just going to explore or display or show the nodes that are directly connected with system 1 thinking dominates. I can choose the layout I'm going to use for this focus, right? So right now I'm just using the preset layout, which means I'm using the layout that corresponds to this graph right now. And then this way I can really analyze the system 1 thinking dominates. Just I have isolated the subnetwork that contains only the neighbors of system 1, right? I can also change the layout. So here I'm going to use a Dagger layout. And then by focusing on this system 1, now I have a new automatic layout that has been triggered for displaying nicely these subnetworks, right? And then, so what are the component of system 1? So we have the time pressure, we have the emotional state, we have here then the information overload, fatigue, and then in red, we're going to see what can be done in order to reduce the biases that comes from system 1, right? So deliberate reflection, decision framework, and emotional regulation, right? And then, so I exit focus. So just make a right click on the graph and choose exit focus. And then we can do the same thing, for example, for the availability heuristic. So I just click on the node, the layout, and then I have a description of this kind of bias. So the recent vivid experience. Then we have the, again, emotional state here. And then we see in red what can be done to reduce the availability heuristic. So obviously we have the well-known statistical Bayes rate used, right? Exit focus. And now, so we can obviously zoom in this graph. So here we see one of the consequence of cognitive bias when we do have a cognitive bias. So we have the overconfidence in judgment, and in yellow you can see what can be done to reduce the impact of this. So we can train the experts, we can have a diverse input team, and so on. Right? So now this allows you, so these little features allows you to move the menu from the right to the bottom, right? So depending on the typology of your graph, sometimes it's better to have it at the very bottom. So here it's good on the right. And then I can also change the way the nodes are represented, right? So I can use disks. So this is more like in the default BayesiaLab setting. So we can use simple badge and also badges with comments, right? So we have now this representation. So you can see, if you're familiar with BayesiaLab, that this is the same kind of representation. And then for the links, we can display the comment that is associated with the link by using labels. In that case, it's not very convenient because they are quite long. So that perhaps better just to use also badges. So then you can use the feature adjust arc labels here that will automatically, try to find the best layout for these comments. So depending on the information you have in the node and the comments that are associated with the links, you have to play a little bit with the interface to find what is the best layout algorithm, what is the best type of representation of the node, what is the best way to represent the relationship, right? So if I use, for example, circle here layout, this is probably not the best one. We're going to see later that it can be useful for some networks. So this one, ELK, is quite nice for these risk-centric networks. So we can multi-select nodes here and move a little bit the mitigants here. And then we have also this tool that allows to, to define or to focus on the different classes that are associated with the nodes. So for example, if I select here main risk, I just focus on main risk, then I can select event, trigger, and then I'm going to use control, then consequence, and then mitigant. Right. So now I have these 5 classes that have been selected. And I can use a navigate classes feature here to go through these classes by using control plus the arrows. So with a shortcut, then now I can really explore these classes very easily. Okay. And you have the name of the classes at the upper right corner, left corner, sorry. So this was the very first way to use HellixMap, right? Just to visualize a graph that is already there. So now we are gonna see how we can upload a graph. So it's not gonna be difficult. So we just go to the upload function, and then we drag, or we can open, obviously, click on the button, and then we're gonna have a finder, but here we can also drag a file. So here I'm dragging an XBL file that represents, companies that are customers, and then we can define a label and then a description of this network. Right? And here we have to choose the slot we're going to use for publishing. So we have 3 types of slots. So we have what we call the working in progress slots. So these are temporal slots, as the name indicates. So you are using them while you are still working on the network to try to find the best layout and things like that. And then when it's ready, you can publish them as free or public networks. And you can also have, if you have a subscription, you can have a private package, right? So where you're going to be able to share this network only to people you have chosen, right? So right now we are going to use a working in progress slot. And then, so this is the network of customers. We can use a simple batch representation. And then try to see what is the best layout for this network. So this one is the preset one. So which means preset is coming from, so here this is a layout that comes from BayesiaLab directly. And so we can try to another one, Dagger, for example. So we just click on run, and then we have a Dagger representation of this graph. We can use a color one. We can try, the D3 forces. Then we're going to try the Euler or cos here. And then we can also use a search function. So when you have a large network, it's very convenient. So here you see in this search function, you have 3 columns. So you have obviously the node, right? And then you have also the neighborhood. So this is very convenient to identify what are the important nodes, right? So you're going to start. So this one, Nestle, for example, is the node that has the most connection in this graph. Right? So if I click on Nestle on the eye here, I'm going to be able to first, if I click on the node, I'm going to have the description of this node. And then if I click on the eye, I'm directly focusing on this node, right? And then I'm going to be able to use a neighborhood function, or here ask for information, detailed information. So same thing, description, you have the long description. And since it's a network that have been uploaded from an XBL file directly, I also have the probability table. So here I know that Unilever is a parent of Nestle in this graph. And here we have the conditional probability distribution, which here represent, it's a semantic network. So it represents embeddings, so a relationship between embedding values, so which are not directly interpretable. Right, so now if I click on Save Current Setting as Preset, this is going to be my new preset, right? So when I will switch back to preset, this will be this layout. So now same thing, I'm gonna focus on Nestle just as an example to see the neighborhood 1. If I increase, I said 2, I'm gonna have more companies obviously in this subnetwork. And then I can change the layout here with Dagger and see here a representation of this network where we can see that everything makes sense. These are really just purely semantic correlation in this graph, right? So now let's suppose I'm happy with this layout, with this setting. So I can change the publication option, and I'm going to choose now a public slot, right? And then I know I still have 10 slots. So now it's public, and I can click on the tools here at the very top to create a link. So here I'm not only copying the link in the clipboard, but also automatically generating a QR code, right? So I can copy the image, and then here you can access directly this network. So since it's not really easy to use a QR code with a computer, it's with a phone, it's okay, but it's gonna be a little bit short on a smartphone. So I can also send you this via the, if it works, does it work? The call to action here does not work. Here it is. And so I think now you should be able to click on this link to have a look, and if you want to play a little bit with this network, right? All right. So this was the first example to create your own map, was to upload an XBL file. Now we're going to see how we can publish one from BayesiaLab. So we have BayesiaLab open here, and we have this network, which is about radar colleague, right? So we have here everything is in French, but at the end of the day, it's in French here, but it's also, if it works, does it work? Come on. It's stuck. Yeah, better. And so here you see déshydratation, that's the name. So this is a French name, but the name of the node is dehydration, right? So we have the names of the nodes are in English, the comments are in English, but the long name that we are using here in this graph are in French, right? So we can obviously change that in the BayesiaLab network. And then I'm going to use tools here and then publish on HellixMap, right? So this will trigger the opening of this authentication windows. I have to put my credentials. And then this will also automatically open a browser, right? So here you have now, so it's very efficient. So very often when I have a network that is quite large in BayesiaLab, I do this publishing and directly go to HellixMap just to explore the graph, because it's more convenient than doing that directly in BayesiaLab. And then same thing, I can try my different layout algorithm. So here, this one is quite convenient. So we see everything is in English here. And then we can save this current setting as preset. So now this is going to be our preset. And so in this graph, you see, if we want to explore it a little bit, we see that the renal colic directly depends on the urinary tract obstruction, that mainly depends on the stone formation. And you see the causes for that. So you have dehydration, you have dietary factors, metabolic disorder, genetic predisposition. And then you can see that there is only one red connection in that case. This is fluid management, which consists in drinking, right? So quite easy. And otherwise, you can see in yellow too the alpha blocker therapy that will help a lot. And I know what I'm talking about now, right? Because I have experienced this a few days ago. So here now we can also, if we click on use short description as labeled here, this will switch on. We have to work a little bit on this because this corresponds to the long name in BayesiaLab, but here it's a short description. And so we are switching with the French version of the name. So in the next release, we are going to have also tools for translating the graphs not just two languages. Indeed. All right. So now it's still my preset now. So in this way, it's better. And as usual, we do change publishing options to have a public network, right? That I can then share to everybody. So this is this link. All right. So now we are going to see how we can use Hellixia directly within HellixMap, right, for generating these different types of graphs we have seen so far. So there are two ways to create graphs. So the first one is to use what we call the open-ended questions, right? So where you enter your questions, so there are absolutely no constraints. And then based on this question, you can generate a knowledge graph, you can generate a causal semantic diagram, a semantic flowchart, a causal network, or a risk-centric causal network. The second way to create graphs is to do document analysis, right? So in that case, you are going to upload one or more document, and then based on these documents, we are going to generate knowledge graph or causal semantic diagrams, right? So let's start with the open-ended question. So in this case, you see it's on the right panel. But to be able to do that, so first here, I'm going to uncheck the show public graph. So this way, I'll just see my two public graphs. And then I go to profile, right? So this way, I'm going to be able to define some preferences. So here, I'm going to just say that I'm in Paris, right? And then I'm going to also define what are the API keys that I have. So just to let you know that since yesterday, we have also provided DeepSeek API keys that comes from Bayesia. So that is available for everybody. So this way, you can directly use HellixMap to create graphs just to see if it can bring you something without having to populate these fields with your own API keys. So obviously, there are some limitations when you are using our key, but so if you set your keys, you are going to have less restriction. So this is like a freemium package. So this is very first tier here is to use the Bayesia key, and then you are going to be able to create a network, but with some limitations, right? So, but here I'm defining my own key, so I'm not going to have limitations, except that I'm not, in the professional tier, so I don't have private subscription here for the moment, right? So I have defined my profile, and then I can enter my question. So here I'm asking to compare Stoicism and Epicureanism, right? So it's in the context of, obviously, philosophy. And I can also upload a context file. So this context file here is the same thing as the knowledge file in BayesiaLab, right? So this is just a document that you can upload to give some context to the LLM, right? Then you have a parameter to control the complexity of the graph, right? So it goes from 0. So this 0 is going to be the default. So where the LLM is going to choose a complexity for you to something like 100 when it's not constrained. So it will generate a large network. You can choose the language that you want to use. You can choose your LLM engine. So since I gave only 2 keys, I have the Anthropic LLMs that I can use, plus the DeepSeek LLM. And then in the type of graph, I have my 5 options here. So knowledge graph, causal semantic diagram, semantic flowchart, causal network, and risk-centric causal network. So I'm going to choose here a knowledge graph, and then this is running. So it's obviously fast forwarded here for this video. And just to let you know that you have to refresh. So in this version, you still have to reload or refresh your page to see how the network is, because it's asynchronous, right? So this is something that you have to do. So every minute you can, or every 10 or 50 seconds, you can refresh your page and see if the network has been finally created. So here it's pending, and in the meantime, I can ask the exact same question, right? But instead of using the default graph complexity here, I'm using 20, right? Just to compare the impact of this parameter. So the first one is running, the second one is pending, and then now it's okay. So the first one has been done, and then when I click on technical information here, I can see at what time I run this, what was the parameter I use, and so on and so forth, right? And then I'm going to go to view to see my comparison between these two philosophical current, right? So we have this graph. And so if I use labels here, it's okay, because we don't, the comment associated with the relationship are not long. And then I click on neighborhood on stoicism, just to have a look at the definition and layer, layout. And then we can analyze what is stoicism, right? So it's a Hellenistic philosophy that was created by or founded by Zeno. And then we can go back to Epicurean, not easy to say for a French guy. And so it's also coming from the Hellenistic philosophy. Epicurus has founding this philosophy, this school of philosophy, and then we can exit focus, right? So we have like two networks that have been merged, if you will, that compare these two philosophers. And then, so if we switch to just to see what is the best representation of this network with the labels associated with the link, we define this as a preset. And then we go back to the workspace. So this one, if I click on view, so this is the one that was generated with a complexity set to 20. So we can see that we have more nodes than in the other one. So we use degree again. And in this one, so we can test different layout algorithm. And for this one, the circle layout is quite nice, because we can see the two schools here. And then we can see what are in common and what is quite different between these two. So here a little bit of positioning. And then we see that, so this is my default preset. If I test another one, so this one color is not really cool. This one can be useful, but we have to extend a little bit the links. So we can see the two schools here. Helk can also be interesting. And cos is useless in this case, so we go back to our preset. All right. And then we see that, well, we have atomisms here for Epicureanism. We have the garden, so this way where it was the school was given. Here we have the logos from the Stoicism, and so on and so forth. So ataraxia. right? So now I'm publishing this network. As you can see now, I have some private subscriptions, so which I'm not going to use them, but this is when you have a subscription, you can have these private ones. And then I can share. So I'm going to also publish this one. And then we can share the network. So this is this one. And for this one, I did not create the second link. So you're going to have to use a QR code if you want to see it. Oh, but at the end of the day, once you are connected, you're going to be able to access all these networks, right? So now let's see how we can use Hellixia for analyzing a single document, right? So in that case, we can create knowledge graph and causal semantic diagrams. So we go in document analysis, then we upload the file. So here I'm using the illusion of thinking. So the recent article from Apple about understanding the strengths and limitations of reasoning models. And so I'm just uploading the file here. And then I can choose the number of chunks. So the chunk is a segment of the network. So when you have documents like that, you can define how you're going to split this document, because if it's too large, you cannot just analyze 100 pages like that. So you have to decide how you're going to split this document. So here I'm going to just use, since it's just an article, I think I use 2 or 1. And then my engine is Claude 4, and I'm going to use a knowledge graph. Right? So same thing, it's fast forwarded. And then we have the generation of this network. We use the ELK layout with label here and simple badge for a better representation. So I don't know if you read this article, but so this is I think a nice representation of the content of this article. So they have really, evaluated the capability of reasoning models by defining, 4 different types of tasks: Tower of Hanoi, checker jumping, river crossing, and block words. So allows them to really control the complexity. They are also avoiding, thanks to that, the mathematical benchmark that can suffers from data contamination. So you have the definition of all these entities. So as I said, they can control the problem complexity, and they see that there is an accuracy collapse. Then, here we have also a scaling limitation. You have the 3 performance regimes that have been highlighted in this article. And so here, this is when we focused on the large reasoning models. So we see we have 4 engines here: OpenAI, DeepSeek, Claude, and Gemini. And then, so we can really explore this article this way. So here we have an inference compute budget. We see that these reasoning models have been learned or tuned with reinforcement learning that develop self-reflection mechanisms. There is also a chain of thought, and they also use algorithmic reasoning, and it was, they were struggling with that, right? And then there is also, an overthinking phenomenon. So here you really have the most important output of this article, right? So I'm saving this as a preset. I'm publishing this network, and then I can publish it and share it, right? So this one is this one. Okay, and now I can also re-show, the public graph here. And what I'm going to show you now is the analysis of this book, the Smith General Urology. And it's a book of about 800 pages. And that I use DeepSeek for creating this network that analyze this big book about urology. And then obviously it's not easy to navigate in this set of nodes here. So when you use the search function, so we can see that we have a network made of 1,623 nodes. And then we see that this is a neurogenic bladder dysfunction, I think, that is the most connected node. And if I search for kidney, then I see that this node has 18 neighbors. And if I just focus by using the my neighborhood function on this dimension, by using the Helk layout, I have then some networks that really focus on kidney. And then I can also focus on your tier in this one, where we have this subnetwork. So you can really navigate in the graph by using these neighborhood features that allows you to really just focus on subnetworks, right? And so this is this one, all right? Then we can also use Hellixia for analyzing multiple documents, right? So not just one, but multiple. So in that case, I use a document analysis, and I am uploading here 2 articles that belong to the field of dermatology. And so it's about, aging. And then I define here how many chunks I'm going to use for analyzing these articles. So it's going to be applied for each of these articles. I'm choosing the engine I want to use and the type of graph. So now I'm using a causal semantic diagram, and I'm generating the graphs. So same thing, you have to think about using the reload function, so to refresh, to see how it's progressing. If you click on it, you can also see have an evaluation of the progress. And then when you click on view, here we have the networks that have been generated by using these 2 articles, right? So this is the graph, a little bit of layouting here, hiding this side panel. And then I can use the classes here. So I have 1 class per document. So if I check these 2, I'm going to be able to navigate to display the network corresponding to each article. So if I use a shortcut for navigating into the classes, so right now, as you can see on the upper left corner, I'm focusing on the network that we're analyzing French women, right? So this is the first article. And then if I continue here, this is the Chinese one, right? And then if I go back, this is the network that merge these 2 documents. So this is a graph that is based on these 2 articles. And then I can also, you have some classes that have been automatically generated. So here we can focus on what are the clinical signs that have been used for estimating aging here. So wrinkle, ptosis disorder, pigmentation disorders, vascular disorders, and skin texture. And then we can also explore the chunks, right? So when you see chunk 00, this is the first chunk of the first document. So here, chunk 00 is, so this is a 1. This is a network that has been created by using the first segment of the first article, right? Then we're going to have the segment 2 of the first article. And then this is the third one. And then we have the first chunk of the second article, the second one, and the third one. And then we have all these nodes now. All right. So now we're going to see the last feature I want to show you today. This is how you can use Hellixia for augmenting an existing graph, right? So two ways to do that. You can use open-ended question or use a document analysis. So we still are in the same network as before. So this corresponds to the knowledge graph or the causal semantic diagram generated on 2 articles. And if I make a right click on the graph, I can here use Hellixia, and then I will be able to add another article, right? So here I'm using a third article, and then about Japanese women now, I define the context, the methodology, the number of chunks. I'm going to still use 2 in this case, the engine, the type of graph, and I can check if I want or not to augment the existing graph or just create a new one. So here, obviously, I'm augmented it. Okay. So this is running, so you have to refresh, and then we can view the result. So we have a new graph that contains the first one, plus now another graph that had been connected to this one that was generated based on the third article on Japanese women, right? So here you have now a graph that correspond to, or that had been generated based on 3 different articles, right? And here I can search, for example, since we are analyzing French, Japanese, and Chinese, let's suppose I'm searching for Caucasian. So I search Caucasian here, and I can search within the label, the short description, or the description. So here we have a node, ethnic differences, that contains Caucasian, and then I can focus on this, for example, on this node, right? Where I see that I have here the facial aging signs and the skin aging, right? So I exit the focus here, and now the last feature consists in, for example, focusing on soy extract here. So I make a right click on this node, use Hellixia, and then here this is triggering the open-ended question analysis if you want. So I have the node at the very top, so the name is soy extract, and I can use it for creating my question. So I can just say, okay, I want to use a label, I want to use a description. So this is my question. Obviously, I can edit this question, but at the very end, we are using the stated node for creating a default question, right? Then I can define the context, the methodology again. I don't have here now, I don't want to use any knowledge file, so I'm just using the basic knowledge of the LLM engine. I am choosing the graph complexity here, so I'm going to use a default one and create a knowledge graph and augment my existing graph with that. We refresh, and then we get the result. We use our best representation here, degree, year, and selected class. We can see if I focus on the class generated one, we are going to focus on the knowledge graph that has been created on soy extract here. So that allows you to understand a little bit more this entity, this concept, if you will, and that has been directly integrated in the network that had been first created with 2 articles, then we added a 3rd article, and now we have a knowledge graph on one specific node, right? So this is where it has been incorporated. So this was the last feature, and I think we are exactly on time for once. So thank you very much for your attention.
Thank you very much, Lionel. Very much appreciated. I haven't seen all of the latest features of HellixMap that you just shared, so I was certainly very impressed. So thank you very much, Lionel. Now it's 12 noon. We're out of time. We have a few questions, but most of them I think we can easily answer offline. So this brings us to the conclusion of today's webinar. But before we sign off, I'd like to highlight several upcoming events. Let me just share a slide here. Hold on. How do I make this large? Here we go. Yes, these are our immediately upcoming events. We have a free webinar on July 17th that will be about smarter segmentation. So there we will talk about combining Bayesian networks, BayesiaLab, and utilizing Gen AI to talk about consumer segmentation, to decode consumer diversity, etc. So that should be a very interesting topic. And I think we already have like 75 people signed up for this particular webinar. Then we're starting up our free in-person seminars again. This will also be about Gen AI, but in a much more thorough format. These will be half-day or 3-hour long seminars. And we'll start off the first one in Cincinnati on August 12th. And then we will also have one in Chicago on August 14th. More cities like New York City, Atlanta, etc. are to follow. For that, please check out our website. Under Academy, you can see all the upcoming seminars and events that are planned. And before we sign off, let me just share our very last slide here. I want to highlight our BayesiaLab conference in Boca Raton, Florida in November. Please do consider joining us, or better yet, think about presenting some of your work. We still have several presentation slots open. So with that, I'd like to thank Lionel again for his presentation. I'd like to thank you for your time and interest, and we hope to see you again at one of our upcoming events in the future. Have a fantastic day.